At the end of the lesson, you are expected to identify density-based cluster identification, describe indications of anomalous behavior, and appreciate the use of clustering in anomaly and fraud. So in our former discussions, we have said that when we have a multimodal distribution, just like for example, this kind, then the heuristics that we have mentioned, which is more than 3 standard deviations, would not be applicable then. So the best thing that we're going to do is we have to resort to cluster, which means that the data set should be divided into clusters. So the question is this: what is a cluster then? So a cluster is a collection of points that are near to each other. How do we define anomalous points in a cluster? So I guess this is the question that is really very important as far as identification of anomalous behavior in a cluster is concerned. So we have here a data set. These are the different points we have in our data set. So as you could see, we have a lot of points in this part of our graph. Just for example, we do have a graph in here. And also, as you could see, we do have some points here below this cluster of data points. So if we're going to examine very much closely, we could see that these points here may show similar attributes because they are near to each other. And these points here below may show different characteristics because the distance is very far from the ones that we could see in here. So basically, when we have this kind of situation, there are 2 things that we need to clarify because these 2 things are very much important in understanding anomalous behavior. The first one is that the clarification of a cluster. So it means to say that we have to very much clear when it comes to what kind of rule we're going to define so that we can be able to identify how many clusters we're going to assign to a certain data set, or in what way we're going to cluster certain data points. So it could be that in this kind of scenario, we can define 3 points or 3 clusters for these data points. Or it could be that we can just have 2 clusters for these data points. It depends on our analysis. The next thing is that the meaning of the distance of the points. So just earlier, we have said that these points may be considered anomalous because the distance is far from the points that are clustered in this part of our data or of our graph. Here, we have to understand the distance of the points because this would tell us whether or not a certain point is anomalous. So speaking of distance, the most famous one for understanding the behavior of data point is the density-based cluster identification. So what is this one all about? So let's try to examine this one. So for example, we do have a graph in here, and here we could see different data points. So as you could see, we have here a cluster of points above the points, a lot of points here that if we are going to take note, they would show similar behavior or tendency. So what's the meaning of this? So the rule is this: when the relative number of points are substantially higher, or it could be lower than the entire region. In this case, we have these points which are substantially higher than this region. Then we could say that this point or these points form a cluster which can exhibit a different tendency or behavior. And this means that these points are suspected to be anomalous. Now, the question is this: I know that you are also questioning yourself, if not asking yourself, about this one. What are we going to do then when we could see this kind of situation? Are we going to just impute the data? Are we just going to delete them? One possible thing that we're going to do is that we're going to delete them. And another thing is that we're going to set aside them because they may show a new tendency or a new behavior of the real world. Set aside them, right? What is this for? Why do we have to study this? Our data is not always normal. it can be multimodal. It is for this reason that clustering finds its use in identifying anomalous behavior. Understanding the behavior of collected points, their respective distances from the center, is the foundation of identifying anomalies. After all being said and done, let's try this. What is density-based cluster identification? How do we find anomalous points in clustering? Please write your answers in a comment down below so that we would be able to have a very rich interaction of ideas and we can learn from each other. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free like Machine Learning Essentials, Deep Learning Mathematics, and a lot more. Here, you can always learn an upskill for free.